Well, let's go ahead and start. And first thing we'll take a look at is section 2.1. And I won't cover all these topics in here because I just won't have time to cover them all. So I'll just kind of jump around a little bit. Now, the first topic is plotting points on a rectangular coordinate system. Now, when you're given a point, you're given the x part and you're given the y part. So, for example, if we want in the graph 3, -1, we go to 3 on our x-axis, and the positive numbers over here, and then going in this direction. This would be a -3 over here. And then we go to a -1 on our y. If I go up, then that's going to be positive, and if I go down, then that'll be negative. So at the intersection of 3, -1, that's where we put our point. We kind of put the number in the wrong place there, but you see how to plot the point. Now the next topic is the distance and midpoint formulas. And given 2 points, x1, y1, x2, y2. Now those sub 1s and sub 2s represent that they're different values. For example, x sub 1 and x sub 2, they're both x, so that indicates they're both x values, but the sub 1 and sub 2 indicate they're two different x values. Now after we have the points there, then let's take a look at the midpoint formula first. Our midpoint formula says m is equal to x1 plus x2 divided by 2 and y1 plus y2 divided by 2. So for example, if I have 5, -1, and 7, and 3. Now our goal is, with the midpoint formula, is to find the point exactly in the middle of those. If I plotted those, I'm trying to find one exactly in the middle. Well, I need to label them first. This is my first point, so I'll label this as x1, y1. This is my second point, so I'll label that as x2, y2. Doesn't matter which one you say is your first point, which one you say your second point. The formula works out the same. So for the midpoint, we're going to add together the x parts. So I got 5 plus 7 divided by 2, and we'll add together the y parts. So we got -1 plus 3 divided by 2. That's going to give us 12 over 2. -1 plus 3 is 2 over 2. 12 divided by 2 is 6. 2 divided by 2 is 1. So our answer would actually be a point, and it would be 6, 1. Now we also have the distance formula. And distance formula, given those 2 points still, your distance is equal to the square root of y2 minus y1 squared plus x2 minus x1 squared. So let's take a look at an example. Given the points -3, -1, and -4, -8, we want to find the distance between them. Let's first label our points. This is my first point, so I'll label this as x1, y1. This is my second point, so I'll label that as x2, y2. It's always a good idea with the distance formula to go through and replace all of your variables with parentheses before you plug in your numbers. And I'll make the outer parentheses a little bit bigger so we can see the difference between them. Okay, so our formula is y2. Y2 we said was -8. And this is y1, which we said was -1. This is x2, which is negative 4. And this is x1, which is negative 3. Then to simplify that, we got negative 8. Negative negative becomes a positive, so we got negative 8 plus 1 squared plus negative 4, and here we have a negative negative, which becomes positive. So we got negative 8 plus 1 is negative 7. Negative 4 plus 3 is negative 1. Negative 7 squared is 49, and negative 1 squared is 1, which gives us the square root of 50. Now you should always simplify your radicals before you go on. And remember, you can use a tree method to come up with prime factorization. 50 is divisible by 2, 2 times 25. 2 is prime, so we circle it. And 25 is 5 times 5. And these 5s are prime, so we can circle it. So we've got square root of 50 is equal to 2 times 5 times 5. Remember, with square roots, we're looking for pairs of something. Here's a pair of 5, so this pair of 5 is going to come out as a single 5. So we're going to have 5 square root of 2. Now, if they want a decimal approximation for that, you plug that in your calculator and round to however many decimal places. Let me clear that off. Then we'll look at the next type. Graph equations by plotting points. Okay, let's say I got y is equal to 3x minus 1. By plotting points, we'll build a t-chart. The reason why this is called a t-chart is because this looks like a T. You have your x and y here. And you're going to pick x values. Now you want to keep them fairly small. You don't want to put in like 1 million typically. Keep them close around 0. Maybe I'll plug in negative 1, 0, and 1. Then, for each one of those, for example, the x equals negative 1, we're going to plug them into our original problem. So we've got y is equal to 3 times negative 1 minus 1. That's negative 3 minus 1, or negative 4. Then we'll plug in x equals 0. So we're going to have y is equal to 3 times 0 minus 1. 3 times 0 drops away, so we got negative 1. And our last one, x equals 1. We're going to have y is equal to 3 times 1 minus 1. 3 times 1 is 3, minus 1 is 2, so that'd be 2. Now if I were to graph this, we'd have to plot our points. So I got negative 1, negative 4. We got 0, negative 1. And we got 1, 2. And then I draw a line through it. It's supposed to be straight. Use your imagination. And that would be our graph. Problem with plotting points is you pretty well have to know what your graph looks like before you begin. Now think what I'm saying. You have to know what it looks like before it begins. Well, if you already know what it looks like, then why are you graphing it? We're going to find that the graphing calculator is a step up from this, where it'll just give us a graph and we don't have to really understand what we're looking for. If you want exact details of how to find the graph, you'd go on and take a calculus class of some sort. Problem with plotting points is, let's say I'm the best point plotter there was, and where everybody else was happy with just 3 sets of points in my t-chart, I had to have 8 or 9 or 10. Let's say I come up with this. And so you can look at this, you see it's a U-shaped graph. Or is it? Maybe what it is a heart-shaped graph. You just didn't plot enough points to see that. Maybe it goes up like this, then comes back down over here at x is equal to 500. which means you just need to put another 500 data points in your t-chart. You would have saw it come back down. And maybe this over here comes back down at negative 500, but then comes back up at negative 20,000. You just needed to put 20,000 points in your t-chart and you would have got the picture of the graph. Now we're going to see the graphing calculator presents a little bit better picture of this, but still is not perfect. This might be our standard viewing window on a graphing calculator. And I could see the heart just fine, but then this, I don't see it coming back down. Now in college algebra you learn some techniques to help you see whether it's coming back down or not, but the class where you truly find exactly what the graph looks like is calculus. There's usually a whole chapter in that class where you cover that. Okay, so that's plotting points to come up with the graph. Now it tells us to identify X and Y intercepts. Identify. I'm going to show you two different ways. And let's say my graph looks like this. And I ask you what the x-intercepts and y-intercepts are. Now your x-intercept is where the graph touches or crosses the x-axis. The y-intercept is where the graph touches or crosses the y-axis. So as I look at this problem here, if the question is what are the x-intercepts, I see it crosses at -1 and crosses at 3. Now sometimes books write it that way. Oftentimes they'll put it in the point form. So that'd be -1, 0 and 3, 0. Now our y-intercept, I can see it crosses down here at 3, and that would be 0, 3. So you're looking where it's crossing the axis. This horizontal line right here is my x-axis. This vertical line right here is my y-axis. And so where it's crossing or touching, it's right there, and right there. Now that's if you're given the graph. If you're given a problem, we got y is equal to 5x plus 2, for example. And the question is asking you to find the x-intercept and y-intercept. Now no matter where you are in algebra, if it's asking you to find the x-intercept, y-intercept, these steps are still the same. So finding the x-intercept. What we're going to do is we're going to plug 0 in for y and solve. Now finding the y-intercept, we're going to plug 0 in for x and solve. It's always the same. When you're finding intercepts, you always plug 0 in for the other variable. So for this one, for the x-intercept, we'll plug 0 in for y. So we're going to have 0 is equal to 5x plus 2. And then we want to solve. So I take the 2 over, becomes a -2. And then we'll divide both sides by 5. And those 5's cancel. We got x is equal to -2/5. Now x-intercept is oftentimes written in point form, so that would be -2/5, 0. Now for a y-intercept, we plug 0 in for the other variable, so we're going to plug 0 in for x. So I got y is equal to 5 times 0 plus 2, or y is equal to 2. So this point would be 0, 2. And those would be our intercepts. Now graph the equations using a graphing utility. So let's talk about this. if I want to graph y is equal to x. And I'll have a full YouTube video of this out here, so I'm just going to do a couple of them. Okay. So if I want to graph y is equal to x, I'm going to press my y equals, which is right here. Okay, let me set my calculator back. I was working trig a couple days ago. Okay. Okay, so now graph. We're going to press our y equals, press our clear. Now y equals takes you to this screen. Clear clears out whatever's on the line. And then we want x. So I push my x key, which is right here. And you see I put x on there. And then I press graph. And that would be our graph. Now if we wanted the values from the t-chart, you see where it says table? Well, if I go to second window, that goes into table setup. And you only have to do this one time. If I down arrow to the independent, right arrow, put my flashing cursor on ask, and press enter one time, this will stay this way from here on out. So now if I exit out, and you can exit out of anything on your calculator by doing second mode. Now if I go to my table, if I do second graph, I got some numbers here, let me clean them out. Earlier we built a t-chart where we plugged in x equals -1, 0, and 1. Well, you can plug in -1, 0, and 1. And it'll build a t-chart for you. So it's really nice in that sense. Now let's take a look at y is equal to x squared. I'm going to go back to my y equals, press clear, I do my x key and push my x squared, and you see when you do the x squared, it doesn't put the x on there. All it does is put the squared on there. So that's why you have to push the x key first, and then push graph. And then that would be our graph. And again, if you want to build a t-chart, you can go to your table. If I do second graph, and you can plug in whatever values you want here. To clean out old ones, you just press your delete key. So I could put in -2, -1, 0, 1, and 2. And you see you get your values. Now, I'm going to give you the steps for fixing your graphing calculator. At some point, if you're using a TI-83, TI-84, you'll mess up the graph. The graph mode. So fixing graph mode on the TI-83-84. Step 1. We want to unhighlight plot 1, plot 2, and plot 3. Second thing we want to do is clear out Y1 through Y0. And then third thing is we'll do zoom, and we'll choose Z standard. Now these probably fix perhaps 95% of the problems you run across on your calculator. Okay, if I go back to y equals, you see across the top it says plot 1, plot 2, and plot 3. If I up arrow and put my flashing cursor on plot 1 and press enter one time, you'll see it highlighted. Now one of three things will happen if you press graph at this point. One, it'll work, and mine looks like it worked. Second thing will happen is you'll get an invalid dim, and if you get that, just do an enter on the quit. Third thing will happen is you'll have extra boxes on your screen. Well, either way, on any of those, if you go back to y equals, to take the highlighting off of plot 1, you do your up arrow, put your flashing cursor on plot 1, and press enter one time, and then you do your down arrow. And then if you press graph, it'll get rid of whatever error you had or extra boxes on your screen or so forth. Now let's take a look at y is equal to x to the third. And then we'll stop after that one. Because again, I'll have the full YouTube video out there so you can go and watch it and see all the different basic building blocks. So press my y equals, press my clear, I go to my x key. How you do a power is with the caret here. And then 3, and then graph. And that would be your graph. So again, it really does help have a graphing calculator. If you don't know what it looks like, you can just plug it in and then see. Okay, let me clear that off. Section 2.2. Write an equation of a circle in standard form. Typically, you're given some information when it asks you to write it in standard form, but let's first talk about what standard form is. When you got circles, your standard form is x minus h squared plus y minus k squared is equal to r squared, where hk and r are numbers. Now your center will be hk, and it's a point. Your radius is going to be r. Now in some cases, you may be given the problem in standard form. Like this right here. Now standard form does not mean you have a minus in each one of these. You can have a plus or a minus. All it says, you can have x plus or minus a number squared plus y plus or minus a number squared equals a number. Now whatever numbers with your x will be your h, and it's always going to be opposite sign. So h is going to be -3. Whatever numbers with your y will be your k, and it'll always be opposite sign. So k is +7. Now if you're wondering why is it opposite sign, my formula has a minus in there. Whenever you have a minus in your formula, that always flips signs. And this is going to be our r, and we'll take the square root of whatever number's here. So we'll take the square root. So we got r is equal to square root of 16, or r is equal to 4. So then, now that we've identified our hk and r, our center is going to be h and k, which is -3, 7. And our radius will be r, which is 4. Now, on the other hand, if you're given the center to begin with, they say the center is -8, 2, and radius is 3. And that's what this first topic is emphasizing, is write an equation of a circle in standard form. Well, you have to identify your hk and r, and if you're given the center, this is h, this is k, and this will be r. And then you're just going to plug it into your standard form. So we got x minus h squared plus y minus k squared is equal to r squared. So I have x minus, and h is -8, squared, plus y minus k, which was 2, squared, is equal to r squared, and r was 3. So we got 3 squared. Now negative becomes positive, so we got x plus 8 squared, and then we got y minus 2 squared, and then 3 squared is 9. So you do a little bit of simplifying, but then you stop right there at that point. Now this says write the general form of an equation of a circle. And there's a lot of different area that covers. But let's say that I started with, I'll start with this previous answer. General form means you don't have any parentheses. So first thing we have to do is get rid of the parentheses. So we got x plus 8 times x plus 8 plus y minus 2 plus y, or times y minus 2 is equal to 9. So I'll FOIL these. X times x is x squared. X times 8 is 8x. 8 times x is 8x. 8 times 8 is 64. Y times y is y squared. Y times negative 2 is negative 2y. Negative 2 times y is negative 2y. Negative 2 times negative 2 is positive 4, and I'll bring the 9 over. So then, we've got x squared. 8x plus 8x is 16x plus 64 plus y squared. Negative 2y is negative 4y plus 4 minus 9 is negative 5 equals 0. Now I'm going to rearrange these. I got x squared, and I'll put the y squared next to it. 16x minus 4y. And then 64 minus 5 gives us 59. And that's our general form. Now there are some books that will put the 59 over on the right side. But generally, standard form, you put your squared parts together, your first powers together, and then your number at the end like that. Some books will emphasize you cannot have fractions. So if you had fractions, you'd have to multiply by the LCM of all your denominators. There's different ways you see. It'd be nice if there was consistency across the board, but there isn't. Okay, that was 2.2. Let me grab a drink here, and we'll look at 2.3. Number 1 says determine whether a relation is a function. Well, let's look at the definition of a function. Function says for every x there is only one y. Now I'm putting these in terms of x's and y's, but it's much more than that. X is your independent variable and y is your dependent variable. For example, if I want to go out and eat, my money would dictate where I can go. So my money drives the other one. So my money is the independent variable, and then where I'm going to go eat is dependent upon whatever I have money-wise. So you could put for every, instead of x, you could have for every unit you're producing, there's only one cost. For every unit, there's only one profit. Or you could put anything in there. We're mainly just going to focus on x's and y's, but realize there's much more than that. Now this definition works out very well if we have points. So let me clear this off. There we go. And let's say we're given the points 1, 3, 2, 5, and 3, 5. I'm going to do a mapping. So I'm going to put my x values down. I'm going to go for smallest to largest, not repeating any. So I got 1, 2, 3. And then I'm going to put my y values down, going from smallest to largest, not repeating any. I got 3, 5, 5. So I got 3 and 5. Now this point here, 1 to 3, that maps 1 to 3. 2 to 5, that maps 2 to 5. And 3 to 5, that maps 3 to 5. Now our definition over here says for every x there's only one y, which means you can only have one line coming out of each number. So this would be a function. Now if you had a different example where you'd come up with your x's and your y's, and you had a line coming out of here to go to the 3, and you also had one coming out of the 4. Then for every x there's only one y, this would have two lines coming out of it. So this one would not be a function. So not a function. Now that's kind of a hard definition to work with. We got an easier definition for the function. Now this easier definition does not work all the time. In terms of college algebra, it should work for every problem you run across in a college algebra class. But if you go on to calculus, it starts failing in some problems. There's other considerations you have to take into account. But for an easier definition, if you have one of the following, it is not a function. If you have y to an even power, it's not a function. If you have the absolute value of y, it's not a function. If you got the plus or minus symbol, it's not a function. If you got x is equal to a number, like x is equal to 3, then it's not a function. So, if we had more examples that went beyond points, then you had, for example, y is equal to x squared minus 2. And the question is whether it's a function or not, yes or no. Well, if I come over here, I don't have anything about an x to an even power. We have y to an even power, but we can have x to an even power. And this is y to the first power. We can have that, we just can't have y to an even power. Since this doesn't have any of the items in that list, this would be a function. Now on the other hand, if we had y squared is equal to x plus 1, the fact that it has y to an even power means it's not a function. So y to an even power, not a function. One more. If we had y is equal to plus or minus square root of x. I said you cannot have this plus or minus symbol. The fact that we have this plus or minus symbol here means this is not a function. Let me clear those off. Okay, now we're going to take a look at function notation. And let me type this up actually. Function notation has two purposes. First purpose is to give a name. Same as you name a child. For example, if I had y is equal to 3x plus 1, and I had y is equal to 4x minus 5. And I asked you to graph y. Well, your question would be, well, which one? We got two y's. So what I'm going to do is I'll give this one a name. Looks like that. And for my other one, I'll give it a different name. Like that. Now how you read those, this reads f of x, or we even get lazier in mathematics and we just simply say f. This one reads as g of x, or we get lazier in math and we just refer to it as g. Now there's no mathematical meaning there. That's not f times x or g times x. It is purely notation, so keep that in mind. It's a name. You give it a name. Now you can go back and forth. If you got in the form of y equals 3x plus 1, you want to put function notation in there, you can replace the y with f of x. On the other hand, if you have the function notation there, f of x equals 3x plus 1, you can go in reverse and replace the f of x with y. Now our second purpose for function notation is to reduce writing. And let me show you an example to see what I mean. Let's say you had a problem that said evaluate y is equal to 3x minus 2 for y when x is equal to 5. Well, how you'd solve this is you'd go through and you put 5 in for your x. And you'd end up with 13. And instead of writing it that way, you could say that f of x is equal to 3x minus 2, and then you say find f of 5. Now that says the exact same thing as all those words over on the other side. And it's worked the same way. To find f of 5, you're going to go through and replace your x with 5. So then we've got f of 5 is equal to 15 minus 2, or f of 5 is equal to 13. So again, two purposes for function notation. Give it a name and reduce writing. Now this right here is called evaluating a function. So let's talk about that a little more. Evaluating a function. Step 1. Replace all of your variables with sets of parentheses. By the way, if you notice the red appears underneath the words there, that tells me I spelled a word wrong. So word isn't a bad area to create a discussion post because it helps point out your errors. Sometimes it auto-corrects it for you even, depending upon your settings. Step 2. Plug in whatever we are evaluating for into the parentheses. And then step 3 is to simplify. And that's evaluating the function. Okay, so let's see what we're talking about here. Let's say we got f of x is equal to 8x plus 1. And we want to find f of 2. So step 1. Replace all of your variables with sets of parentheses. So to find f of 2, we're going to go through and we replace all of our variables with sets of parentheses. So this x gets replaced by parentheses. Step 2. Plug in whatever we're evaluating for into the parentheses. And that's pretty vague what that says, whatever we're evaluating for. But that'll be whatever's inside the parentheses here. So this is whatever we are evaluating for. So we're going to plug 2 into the parentheses. Again, whatever's right here is what we're going to plug in down here. And then step 3 is to simplify. Well, 8 times 2 is 16 plus 1. 16 plus 1 gives us 17. And that would be our answer. And time yet again is slipping away from me, so I'm going to not show you a second example of that. I'm not going to show you the x and y intercepts of a function, but I will tell you that if you have f of x equal to like 7x minus 2, for example, and you ask to find the x and y intercepts, you can simply just change the f of x back to y and then do what we did before. So if you go back and watch the YouTube video, you'll see how we found the x and y intercept, and it's the same way here. So again, these are interchangeable. If you have f of x, you can put a y there. If you have a y, you can put f of x. Determine the domain and range of a function. So domain of a function. This by default is all real numbers. Except, here's our exclusions, ones that cause a denominator to equal 0, and ones that cause a negative number inside of a radical with an even index. Now there's a third one we list there for college algebra typically, and that's when we get the logs. So we haven't covered logs, so I won't put it. So finding the domain where you have a fraction, specifically the fraction with means you have a variable in the denominator. If you don't have a variable in the denominator, you don't need to worry about it. Your domain is all real numbers, negative infinity, positive infinity. So step 1, set the denominator equal to 0. Step 2, solve. And step 3, put a slash through the equals. We'll clear those off. Then we'll look at an example. Say we got f of x is equal to 5 over x squared minus 8x plus 12. And instructions are to find the domain. Step 1, set the denominator equal to 0. So we got x squared minus 8x plus 12 equal to 0. Now step 2 is solve. And this could be a linear equation where you got x to the first power, or it could be a quadratic where you got x squared. This happens to be a quadratic, and this will factor using the PSD. And it factors as x minus 6 times x minus 2 equals 0. And we talked about the zero product property. You get 0 on one side, you factor the other side, you set each factor equal to 0. So we'll set x minus 6 equal to 0 and x minus 2 equals 0. Which gives us x equals 6 and x equals 2. Now these are the values we cannot have. If we plug those back into our original problem, they'll cause our denominator to equal 0. So x cannot equal to 6 and x cannot equal to 2. Now if the homework requires you to put it in the interval notation, we would go from negative infinity to our smallest number, union, our smallest number to our largest number, union, our largest number to positive infinity. And we'd have parentheses on everything. Okay, finding the domain where you got a radical with an even index. Step 1. Set what is under the radical, radicand, greater than or equal to 0. We can't have a negative number underneath a radical with an even index. It gives us an imaginary number. And then step 2 is solve. So for example, if I got f of x is equal to square root of 3x minus 1. Now, even index. Your index is whatever number is in the slot right here. And if there is no number there, then it's by default 2. So a square root is an even index. So we're going to take what's underneath our radical and set it greater than or equal to 0. And then we want to solve. So I take the negative 1 over, becomes a positive 1. Divide both sides by 3, and we got x is greater than or equal to 1/3. Now if they're wanting this in interval notation, we would put a bracket because there's a line underneath, and would have 1/3 to positive infinity. And that's how you'd write it in interval notation. Now specifically over here, they're saying determine the domain and range of a function. And they're probably referring to a graph. And that's what the fifth one says also. It says look at it from graphically. Now I found the domain, and that'll help you in a few of these sections down here where we did it algebraically. Doing it graphically isn't always the best choice. But let's talk about what does that mean graphically. Usually that's the only way you can work with the range. Let's say I have this graph right here. Now your domain, in terms of x's and y's, is where the graph exists in terms of your x values. So if I come here to -2, and I ask myself if I can go up or down and find my graph, and I can go up and find it. So it exists there. Now over here at -4, I can go up and find my graph, so it exists there. This, as it keeps going up forever, it keeps slowly going left, so it'll keep slowly going left forever, which implies it's going to -infinity. This one, as it keeps going up, it'll keep slowly going right, keep slowly going right forever, so it's going to +infinity. Now for our range. If I come down here to y is equal to 1, if I go left or right, I don't find my graph anywhere. It doesn't go down that far. It doesn't exist there. Actually, our lowest point on our graph is right here, which would be 2. So this is going to go from 2, and then it goes up forever. So it goes +infinity. Now the 2 will have a bracket on it. The only time you put a parentheses on a number is when it's an open dot. For example, if it looked like this, that's when you'd put parentheses. Otherwise, any other time, you always put brackets on numbers. Infinities always have parentheses. Okay, so let's take a look at 2.4. And about halfway through, but I'm not halfway through the material, so I'll start skipping a little bit. Okay, so this talks about linear equations in 2 variables and linear functions. So let me clear this off. And it says graph linear equations in 2 variables, determine slope, intercept form. The graphing we saw up above, but we'll talk a little bit more about how can you tell a linear equation in 2 variables. We have something called slope. Now slope, actually let me write this down first. Slope is the change in y over the change in x. Some people teach rise and run, which is not a very good way to teach it in my opinion. Because it's much more than that. Rise and run gets you thinking distance. You can put anything in here. For example, I went and ate out today. I had a change in finance over change in time. Change in calories over change in time. If you're in business, change in profit over change in time. Change in cost over change in time. Change in revenue over change in units. Whatever that might mean. So you can put anything in here. It's such a universal concept that if you go on to calculus, you'll find that half the class is studying this concept. Now, having said that, all we're going to work with is x's and y's, but realize it's much more than distance. Now, given 2 points, x1, y1, and x2, y2, our slope is going to be given by this formula, y2 minus y1 over x2 minus x1. So if I had a point like this, we got a -3, 1. That's our first point, so I'll label that as x1, y1. And then we have a second point, -5, -7. This is my second point, so I'll label this as x2, y2. Very similar to what we did when we found a distance formula earlier. It's always a good idea when you're working with this to go through and put parentheses in where your variables are before you plug in your numbers. Now we said y2 is -7. We said y1 is 1. We said x2 is -5 and x1 is -3. -7 minus 1 is -8. -5 and a negative gives us a +3. So we got negative 8 over negative 5 plus 3 is negative 2, which would give us 4. So our slope is 4. Now we have something called slope-intercept form. Slope-intercept form is when it looks like y is equal to mx plus b, where m and b are numbers. M is going to be our slope, and b is going to be our y-intercept. So if everything's the first power and you can get y by itself, this is slope-intercept form. Now, in order to plug something in your calculator, the TA3, TA4, you have to have y by itself on the left side, slope-intercept form. If you're graphing these by hand, it really is easiest when you're dealing with lines to have the y by itself. So it serves two purposes. Now remember, slope-intercept form, I could equally put f of x here, and it's still the same. Okay, let's take a look at graphing one. We got y is equal to 2x plus 3. This is in slope-intercept form, so our m will be whatever number's in front of our x, so that's 2, and we'll put it in fraction form, so I'll put it as 2 over 1. Our y-intercept is the number at the end, 3. So if I'm graphing this by hand, I'm first going to go put my y-intercept down, put a point there. Now from that point, we're going to use our slope to come up with the next point. And remember, this is a change in y over change in x. If this is a positive 2, that means we're going to go up 2. And if this is a positive 1 down here, that means we'll go right 1. Now if this was a negative 2, we'd go down 2. If this was a negative 1 here, we'd go left 1. So from that point there, we're going to go up 2, and we're going to go right 1. So up 2 and right 1, and that's where we put our second point. Now after you have your second point, then you draw a line through them, and that would be our graph. So you can see it's beneficial to have the slope-intercept form. You can very quickly come up with the graph, or you can plug in your calculator. Now there's some problems where they'll give you the point and the slope. So maybe they tell you the slope is 7, and they give you a point, 2, 3. And the instructions are to find the equation line in slope-intercept form. Well, let's take a look at the instructions for that. Finding the equation of the line. Step 1, we want to find m. Step 2, plug in the given point for x and y, and m into y equals mx plus b, and solve for b. And then step 3 is write our answer down. We're going to plug in m from step 1 and b from step 2 into y equals mx plus b. So step 1, find m. Well, this one's easy. M's given. They tell us slope is 7. Step 2, plug in a given point for x and y. When they give you a point, they're giving you a specific instance of x and y you can use. So we're going to plug in 3 for the y. M, we just said in step 1, was 7. And x is 2 plus b. And then I say and solve for b. So we got 7 times 2 is 14 plus b, takes 14 over, becomes a negative 14. And we get b is equal to negative 11. A lot of people forget step 3 though. Step 3 says to write your answer down. So we want to plug in the m and b we just found. We said m was 7, and we said b was negative 11. So our answer will be y is equal to 7x minus 11. Now once you have it in this form, you could then graph it. You could plug in your calculator, so whatever's appropriate. Let me clear this all off. Okay. In some problems, you may be given 2 points. So we're given 1 point there, and we're given another point. And the instructions are to find the equation of the line. Well, now in step 1, it's not so easy because the m isn't given, so we have to find m. That's okay. We got a formula given 2 points how to find m. This is our first point, so I'll label this as x1, y1. This is our second point, so I'll label it as x2, y2. Remember, our formula is m is equal to y2 minus y1 over x2 minus x1. We're going to go through and we'll put parentheses in everywhere we have a variable. And then we'll plug that in. Y2 we said is negative 4. Y1 is negative 2. X2 is 3 and X1 is negative 1. So we're going to have negative 4, negative negative gives us a positive 2. 3 and negative negative gives us a positive 1. Negative 4 plus 2 is negative 2. 3 plus 1 is 4, which reduces to negative 1/2. Step 2. Plug in a given point for x and y and m into y equals mx plus b and solve for b. We're given 2 points. You plug in whichever one you want. Both of them will give you the same answer, as weird as that seems. So you plug in whichever one looks easier, and I'll pick the second point. I'm not sure if it's easier, but... So we'll put negative 4 in for the y. M we just found was negative 1/2. And x is 3. And then plus b. Now we want to solve for b. Negative 1/2 times 3 is negative 3/2 plus b. Take the negative 3/2 across the equals, becomes a positive 3/2. Negative 4 times 2 is negative 8 plus 3 is negative 5. So we got negative 5/2 equals b. Step 3. Write our answer. So we want to plug in the m we found in step 1, which is negative 1/2. And the b we found in step 2, which was negative 5/2. And that would be our answer. Let's see. Let's talk about the parallel and perpendicular lines. Let me clean this off first. Now, specifically, they say determine the slopes of parallel and perpendicular lines. I'm going to show you the process for finding the equation of a line given a point in a parallel or perpendicular line. As part of that process, we'll see how to determine the slopes. So finding the equation of the line given a point and a parallel line. Step 1, find m. First substep within that is to write the given line in slope-intercept form. Solve for y. Our second substep is to identify the slope. Our third substep says parallel lines have the same slope, so m is going to equal to, and I'll just put a blank there and we'll talk more about that with our example. Step 2. Plug in the given point for x and y and m from step 1c into y equals mx plus b and solve for b. Step 3. Write your answer. Plug in m from step 1c and b from step 2 into y equals mx plus b. Okay, so let me make up a problem. Let's say it passes through the point 3, -1, and it's parallel to y is equal to, I don't know, 7x plus 20. Step 1. Find m. First substep. Write the given line in slope-intercept form. Well, this is already in slope-intercept form. It's already got y by itself. Not every problem will require you to rewrite it. Our second substep says identify the slope. Now, the reason why we want it in slope-intercept form is so we can easily identify what the slope is. Slope is whatever number's in front of your x. So slope is 7. Now C, parallel lines have the same slope, so m is equal to. So we said it's parallel to y is equal to 7x plus 20. We said the slope of that line is 7. Parallel lines have the same slope, so the m we're trying to find will be 7. So parallel, it's always the same there. Step 2, we want to plug in the given point for x and y. Now up here, again, they give us a point, so they're giving us the x and giving us a y. So I'll plug -1 in for the y. M we just said was 7 times x, which is 3, plus b. And then we want to solve for b. 7 times 3 is 21 plus b. Take 21 over, becomes a -21. And you get b is equal to -22. Step 3. Plug in m from step 1c, which is 7. Plug in b from step 2, which is -22. And our answer will be y is equal to 7x minus 22. Now that's the parallel case. Let's say it passes through the point -1, -5. And it's perpendicular to 5x plus 2y is equal to 3. Okay, so finding the equation of the line given a point and a perpendicular line. Step 1, find m. First substep is to write the given line in slope-intercept form. B, identify the slope. Now C, perpendicular lines have slopes that are negative reciprocals. So m is going to equal to, and then we'll talk about that. Step 2, plug in the given point for x and y and m from step 1c into y equals mx plus b, and solve for b. Step 3, write the answer. We're going to plug in m from step 1c and b from step 2 into y equals mx plus b. Okay, step 1. Find m. First substep is write the given line in slope-intercept form. So we got 5x plus 2y is equal to 3. Now slope-intercept form means you solve for y. So I'm going to take this 5x and move it to the right side. It becomes a negative 5x plus 3. And then we'll divide everything by 2. And we get y is equal to negative 5/2 x plus 3/2. Now b, the reason why we put it in that form is so we can easily identify the slope. If it's in slope-intercept form, your slope is whatever number's in front of your x. The slope is negative 5/2. Now c. Perpendicular lines have slopes that are negative reciprocals. So what we're going to do is we're going to start with the slope from 1b, which is negative 5/2. We're going to write it in fraction form. Now you might look at that and say, well, it's already in fraction form. Well, yeah, this one is. But if you had a different problem where you just had a 5, you'd put the 5 over 1. You can always create a fraction by putting it over 1. And then we're going to flip it. The top goes to the bottom, bottom goes to the top. This is the reciprocal part. Reciprocal means fraction flipped. And then we're going to change its sign. So it goes from a negative 2/5 to a positive 2/5. Negative reciprocal means you flip the fraction, change its sign. So the m we're trying to find is going to be 2/5. Step 2. Plug in x and y from the point that's given. So y is negative 5. M we just said was 2/5. And x is negative 1 plus b. And then solve for b. 2/5 times negative 1 is negative 2/5 plus b. Take negative 2/5 to the left side, becomes a positive 2/5. And that gives us negative 23/5. Now we can't forget step 3 to actually write our answer down. So we're going to plug in our m from step 1c, which we said was 2/5. And we'll plug in b from step 2, which is negative 23/5. And that's our answer. Now there is specifically, like I say, just asking you to find the slopes of parallel and perpendicular lines. But part of that process is how do you find a parallel or perpendicular. So that shows you. Now the other thing I want to show here is to create a model, linear model or whatever, using linear regression. So let me scroll down. Let's say you do have some data points. And we got 1, 2, 3, 4. I got 12, 21, 35, and 51. And I want to come up, excuse me, let me grab a drink. Okay, I want to come up with a model using linear regression. So linear regression, we want to first put these in our calculator. So I'm going to exit out of my graph. I'll do second mode. Remember, second mode exits you have anything. And we want to go put our numbers in. So we're going to push our stat button, which is right here. And we want to go into edit. So we'll do enter on edit. Now you may or may not have numbers here. So if you have numbers, you just simply press your delete, and that'll delete the one it's sitting on. There's a quick way to clean those out, but I'm not going to show it because we're not going to get that much in depth. This is more of a statistics option. And you should have an L1 and L2 there. So we're going to put our X values in L1. So we'll do 1, enter, 2, 2 enter, 3 enter, and 4 enter. Then I'm going to right arrow to L2, and I'm going to put my Y values. So I got 12, 21, 35, and 51. Now I'm going to exit out, so I'll do second mode. And you have to set your calculator up one time for diagnostics and to get the full information. You don't have to do this every time. If you do second, and then we'll press 0 to go into the catalog. So second 0. We want to go down to the diagnostics. And you can push this button that looks like X to negative 1. And that'll quickly go down to the D's. Or you can just simply press your down arrow over and over until you get to the D's. Now we want our little cursor, little marker next to diagnostic on. And then you press enter twice. Okay, like I say, you only have to do that diagnostic on one time. Now, to get our linear regression model, we're going to push our stat button, right arrow to calc, and we're going to choose number 4. This is linear regression. Press enter on it, and then press enter again. Well, that sure came out nice. Not used to them coming out nice like that. Now, if you look at this equation at the top, it says y is equal to ax plus b. Usually when we're talking about linear regression models, we put a hat over this. Looks like that. It's called y hat. As weird as that seems. What that means is that's an estimate. Now we're going to plug in a, which we said was 13.1. So we got 13.1x, and we'll plug in b, which we said was negative 3. This is our linear regression model. Now, how we can use this is, let's say this is in our business. This is going out for 4 years. If I'm wondering what's happening out here at the 6th year, well, we can go to our model, and we can plug in 6 for the x. Now, I'm not very good at decimals, but let's see how this goes. 78.6. Yeah. 78.6 minus 3 is 75.6. So if it follows the same trend, then you're going to see that your y value, approximately, what we're predicting it to be, is 75.6. Now the R. What does R tells you is it tells you how good is your model. The closer this is to positive 1 or negative 1, the better the model is. This is 0.99268 in a bunch of decimal places. This is pretty close to 1, so the model's pretty good. Now, to clear off your screen at any point in time, you just press your clear a couple times, and that'll always clear off your screen if you want to start over. Now, that was creating models using linear regression. And it's also the same as number 3, create linear functions to model data. Well, that's what the linear regression does. It gives you a model that you can then use to predict. To model data means to predict it. Now, section 2.6 is transformations of graphs. Let me come up here and clear this off. Fairly straightforward concept. Sometimes the problems they put on the homework are not as straightforward because you have to think about it at a point level. I'm just going to give it to you at a function level. We have our basic graphs. These are ones you see in any standard college algebra class. We have y is equal to x, which looks like this. We have y is equal to x squared, which looks like this. We got y is equal to x to the third, which looks like this. We got y is equal to square root of x, which looks like this. We have y is equal to the absolute value of x, which is our V-shaped graph. And we got y is equal to the cube root of x, which looks like that right there. Most books have these first 5, and then they'll have a 6th one. Some books have the cube root of x, some have the step function. Seems like every book has their own flavor of the sixth type, but they all have the first 5 types. And I like to show this by example. So if I got y is equal to x squared minus 2. If you got a number at the very end or at the very beginning, this is going to shift it up or down. It's a vertical shift or translation. The minus 2 here means I'm going to shift it down 2 units. Now what that means is my graph still looks like the x squared, still that U-shaped graph. We're just shifting the entire graph down 2 units. So it look like that. On the other hand, and these apply no matter what your function is. It even applies to ones that aren't listed here. If you go on to trig, this same concept applies in trig. If minus 2 is down 2, then plus 3 is going to be up 3. Now this is still our V-shaped graph, just the entire graph has been shifted up 3 units. And that should be our V-shaped graph. I'm not very good at freehanding these. Now on the other hand, if we have a number inside with the x, what does that mean? Well, inside the parentheses, inside the square root, inside the absolute value, inside of whatever. Then it's going to shift left to right, opposite of what you think, unless you think backwards. The minus 2 would make us think left 2, so this is really going to go right 2. Now it still looks like our U-shaped graph. I'm just shifting the entire graph right 2 units. And that would be our graph. The idea of the shifts is that you can very quickly come up with the graph without picking up a graphing calculator. That's a true benefit in terms of college algebra. Okay, now the absolute value of x plus 3. The numbers inside with the x, so it's going to shift left to right. The plus 3 makes us think right 3, so we're going to go left 3. Now it's still a V-shaped graph. We're just shifting the entire graph 3 units to the left. And that'd be our graph. Now you can have negatives involved. Let's say we have a negative out in front of our function. This is going to reflect, flip across the x-axis. Now our basic graph is the U-shaped graph. Looks like this. So when I say reflect, flip it across the x-axis, this is going to flip upside down. So it becomes that right there. And that's what a negative does. Now it's a little bit more than just flipping it upside down, because if you have part of the graph up on top and part of the graph down below, it rotates the entire graph. It's kind of like an axle in a car, if you think about the rotation. Now, if we have a negative inside with the x. So instead of the negative being out in front, the negative is inside with the x. This is going to reflect across the y-axis. Now our basic graph looks for the square root of x, looks like that. And so when we reflect it, flip it across the y-axis, it's going to look like that right there. And there's also shrinking and stretching. I'm not going to go over those. You can read the book, learn more about it, watch the videos, and so forth. But you can have mixtures of these. Let me not show that one. I want to show a different one. Okay, x plus 5 squared plus 3. Here's our basic graph, the U-shaped graph. Now the negative. Negative out in front means you flip it across the x-axis. Flips upside down, reflects. So it looks like that. The plus 5 that's in here, that's going to go left 5. 1, 2, 3, 4, 5. So it would look like that right there. And then the plus 3 means we go up 3. 2, 3, 4, 5. 1, 2, 3. So from there I shifted up 3 units. And my graph would look like this. So again, just by using the shifts, the transformations, I'm very quickly able to come up with a sketch of the graph. That's our reflections, vertical. I didn't cover the shrinking and stretching, but I'll leave that for you to look at. Now the running out of time, so let me think what to show. You can read that about even and odd. People have trouble with a composition of functions, so let's talk about that. And I'll focus specifically just on the mechanics of it. I won't talk about what it's used for. Again, I cover that in the YouTube video where I go into more depth on it. So we got f of x is equal to 3x minus 1, and g of x is equal to 5x plus 2. And you'll have something that looks like this. Looks like fog. That's not fog, that's composition symbol. We're going to rewrite that as function notation. So we rewrite that as f of g. Now I had trouble with this when I was in college algebra. It's pretty simple now that I'm teaching it. F is first year, so F is first year. G is second, so G is what goes second. It's what goes inside the parentheses. I couldn't remember this order for some reason. I had a student a couple semesters ago said, couldn't you think of that composition symbol as of and F of G, so that helps you with the function setup? And yeah, they were correct. That's actually easier in the way I've explained it. Now this is just evaluating a function. You could think of it as covering up the G. So you put your finger over the G, and you're finding f of something. When you're finding f of something, you go to your f of x, and where your x is, you put in a set of parentheses. Same way as if you were finding f of 5. You would go through and you'd put parentheses in where your 5 or where your x was. Then, whatever you're evaluating for, whatever's inside this parentheses automatically comes down here. Well, that's the same way in this problem. Whatever's inside this parentheses automatically comes down right here. But g is equal to 5x plus 2. So we're going to replace the g with 5x plus 2. And then at this point you simplify it. 3 times 5x gives us 15x. 3 times 2 is 6 minus 1. Which gives us 15x plus 5. And that's our answer. Now you can also find the composition going the other direction. So you can find the composition of G and F, which is G of F Now again, you could cover this f up and think of it as g of something. So we're evaluating a function, g of something. So we're going to go to our 5x plus 2, and where our x is, we'll put in a set of parentheses. Now evaluating is always the same. Whatever's inside this parentheses is automatically what you put in down here. So I'll put f in there. But f is equal to 3x minus 1. So this gets rewritten as 5 times 3x minus 1 plus 2. 5 times 3 is 15x. 5 times negative 1 is negative 5 plus 2, which gives us 15x. Negative 5 plus 2 is negative 3. Now notation. On some problems you may have something that looks like this. This does not mean multiplication. It doesn't mean you take the composition of f and g and you multiply it times 2. How you read this is this first says find a composition of f and g. Well, that's what we did right here. We found a composition of f and g. It then says to plug 2 in for the x. So this is kind of a continuation of this over here. We'll put 2 in for the x, plus 5. 15 times 2 is 30, plus 5, which gives us 35. And let's see if there's anything else I want to mention. Graphing piecewise defined functions. Let's do one of those real quick, because that's kind of a hard topic too. Now piecewise, and I won't go into what a piecewise is, but I do in the YouTube video. Piecewise function looks like this. This is when x is, let's say, less than 0, and this is when x is greater than or equal to 0. Now, if our instructions are to graph it, and that's what they're specifically asking, graph piecewise defined functions. Well, what we're going to do first, step 1, is we're going to graph each piece separately. So I'm going to graph y is equal to 3x minus 1 and y is equal to 4x. And here's my y-intercept, put a point there. Slope is m, which is 3, which we can rewrite as 3 over 1. Change of y over change in x. Which means we'll go up 3 and right 1, and that's where we put our second point. And that'd be our graph. Now y is equal to 4x. That passes through the origin, and our slope is 4, m, which will be 4 over 1, which means I'll go up 4, and I'll go right 1. And that'll be that graph. Now step 2 is we want to apply our conditions. What that means is it looks like 3x minus 1 only when x is less than 0. That means here's x equals 0. This is the line x equals 0. And x is less than 0 means we want to keep the left side. Which means I want to come here, and I only want to keep the left side of the graph. Now specifically it's a less than. It does not include that point, so we put an open dot there. Now for our other one. This x is greater than or equal to 0, which means we'll keep the right side. And it's equal to, so it includes that, so we'll put a solid dot there. And that looks like that. And then our third step is to merge those into one graph. So got an open dot here. It's going down like this. This is a solid dot, and it's going up like that. And that would be our graph. And I got more examples, like I say, in the YouTube video if you need more help on that. We've gone an hour and a half, and that's why I'll stop the video, and then I'll take any questions you have. And as always, during the week, if you run across a topic you're not understanding, let me know. I'll create a YouTube video and send it back to you and help you get over that hurdle.